following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Beginning here with colligative properties. Firstly, what is a colligative property? Let's take a read here. A colligative property is a property of the solution that depends on the concentration, which is a ratio of the solute to solvent particles, and not on the individual chemical species dissolved in the solution. Now, two other terms that we're going to be using quite frequently in this lecture series is solute and solvent. Let's take a moment now and define them. The solute is the substance dissolved in the solvent to form a solution. And typically the solute is the component of the solution present in smaller quantity. Solvent is the dissolving medium of the solution. Typically solvent is the component of the solution present in larger quantity. As we'll see, the solvent is typically the water, and it's mostly present in the larger quantity. Now, let's move to our next slide now, and we can elaborate here a little bit more. Examples of colligative properties. Now here, we're going to first generalize, and then we'll talk about each specific colligative property on the coming slides. Beginning here, the vapor pressure lowering of a solution, 2, boiling point elevation, freezing point depression, and osmotic pressure. Thus, the amount of solute that is present, right, in the solvent, in the solution, right, impacts all of these factors here, these properties here. Great. Now, let's begin first with the vapor pressure lowering of a solution. Vapor pressure lowering of a solution. Vapor pressure of a liquid is the equilibrium pressure of a vapor above the liquid or solid in a closed container, which results from the evaporation of the liquid or solid. Now, if we take a look here at figure 5.1, we can take a look at our manometers here to discern vapor pressure. Wonderful. If we take a look at the flask on the right, we see here that we have pure solvent, right? And that vapor pressure for the pure solvent is larger relative to the solution containing a non-volatile solute, where that vapor pressure is lower, and that is due to the solute present, the non-volatile solute present within the solution. Now, what are some factors that we think impact vapor pressure? Firstly, it's temperature, right? Thus, as our temperature, right, is going to increase, the vapor pressure, right, is also going to increase. Now, secondly, intermolecular forces as well, right? Intermolecular forces, as the stronger the intermolecular force, the less the vapor pressure. Great. Now, one other point that I would like to bring up before we get into our examples here is, if you had the two liquids that we have here, that being the pure solvent and the solution containing the non-volatile solute in an open flask, which one of these two do we think would evaporate first, the pure solvent or the solution containing the non-volatile solute? That's right, it would be the pure solvent, right? And that's because if we see here, the molecules, right, they actually escape a lot easier, right, relative to the solution containing the non-volatile solute. And furthermore, say we wanted to find the vapor pressure of a solution containing a non-volatile solute, as we see here. What can we do? We can use what is known as Raoult's law, and we'll take a look at that now on the next slide. Great. Raoult's law. Raoult's law states that the vapor pressure of the solution, right, the vapor pressure of the solution, right, is given by the vapor pressure of the pure solvent, right, times the mole fraction of the solvent in the solution. And what is the mole fraction? We had covered it in a previous lecture series, but we'll just quickly define the equation here, right? It's going to be the mole fraction is going to be the moles of the solvent over the moles of the solvent plus the moles of the solute or solutes. Great, let's actually do an example of Raoult's law now, and we'll do that on the next slide.